Hi everyone, I'm Jessy Li from Linguistics, and we're here to talk and present our team who do and design responsible AI technologies to curb disinformation. We are really a team of 7. I think Min is here today. So we have Matt from the iSchool, Daraj from the School of Journalism and Media, Maria from Information Risk and Operations Management in the Business School, Greg from the CS department, Min from iSchool, myself, and Joe from School of Journalism and Media. What really inspired us is this huge and disconcerting phenomena of disinformation and misinformation. And we believe there is a role for AI to play in collaboration with humans, as well as how this particular phenomena can provide a broader research in developing and testing fair and explainable AI models. So I'm going to start with a recent paper from our team member, Joe, and a really timely one if you look at the title, Russia's Disinformation Campaign During Military Conflict in Ukraine. So what this paper explores is online informational warfare by the Russian Internet Research Agency, IRA, against the Ukrainians during the 2014 military campaign in Donbass. So this is a strategy codenamed Cold War 2.0, introduced by Russia's IRA, and basically they kind of launched a Cold War disinformation campaign and demonstrate how it tries to blur the distinction between fact and fiction by embedding fake news to traditional news media and taking advantage of people's partisanships. So this is a problem. And this is another example. So if you look at this tweet, friends, below, new 5G data communications networks described below. New Bill Gates-sponsored coronavirus vaccine with nanotech will run everything and control everyone who are still necessary, like robots to serve the elite. Get your vaccines now. You're probably kind of familiar with the two pretty well-known conspiracy theories here. The first one is the 5G conspiracy theory. I think it originated in France. I think it was because somehow somebody said there is like a 5G tower being built by the time that the coronavirus outbreak happened in Wuhan. And there's the second conspiracy theory about how lipid nanoparticles used in the Pfizer vaccine that is critical for protecting the vaccine to transfer material to the cells for it to actually take effect, how that is distorted to say, okay, you can now embed robots in the vaccines and control everybody. The light ahead is that people are doing fact-checking now. So this is an article by the Reuters to refute this lipid nanoparticle fake news. However, even though there are professional fact-checkers and more of them, there is a scalability issue. That is, the amount of fake news and disinformation keep growing. Every single day, every single month. There is no way for human fact checkers and professional fact checkers to actually keep up. So we do believe that there is a role for AI to play here. But there will be interesting questions that, and really necessary ones that AI technology must answer as well. So if we consider this technology as an opaque black box, what happens is, let's say you have a claim, and perhaps you have some evidence, and you put that into some sort of opaque machine, and the machine is going to tell you, well, fake news or not fake news. But is that enough? Right? So it is scalable. It can solve this problem. But at the same time, how and when can we actually trust these type of outputs? And how can we actually incorporate explainable and transparent AI technology and incorporate humans in the loop such that we get the human accuracy as well as the scalability of AI. So here are the main research questions for our team. The first one is, how can we design responsible AI technologies to curb the digital spread of disinformation and misinformation? And also, by tackling this very real societal challenge, disinformation, what broader lessons can we actually learn about better design, build, and evaluate responsible AI technologies? So what I will do is to present a series of work from our team members, and I am really excited to present them. I think they are starting to telling us a lot about what AI can do in this very sensitive role. So this is a paper by Matt's group that was presented at CHEER 2022. So the motivation of this work is that, well, here we show that most of the AI systems look like this, right? We are mostly considering a opaque black box that tries to optimize everything and strive for the best accuracy possible. However, a user that is doubtful for online information is probably also going to be skeptical about these model outputs. Furthermore, users may arrive at very wrong conclusions influenced by the model errors because the models are so opaque. The goal is, if we enable human AI teaming, that can really help when the system is transparent and explainable. What you see here is the website built by Matt and colleagues. Here we have a claim: asymptomatic people can transmit COVID-19. Okay, and what is being retrieved is a list of news sources. So here, Nature News, some JAM network, and so on. And there is a score of source reputation. And we also have kind of the news article that talks about this claim. And finally, we have interactive panel of whether the news actually denies or support the claim. So what you can see also down, what is the machine predicted correctness of this claim, synthesizing all the information from above. The interactive component comes from here. You can actually adjust, depending on how you think this news source is, you can adjust whether this is unreliable or reliable. Okay. What you'll see down is that now I've said Natural News is much more reliable than it used to be. We can see that the label true being marked as not the case with this website become much less probable. And same story here. If you say this is really support, not deny, what you'll be able to see is that the probability of true becomes higher. So what they found with this interface is that they found users start dwelling on actually fact-check these news articles, reading it, and thinking about the source reputation much more using eye tracking than if they do not have this interactive interface. And in addition, their mental workload overall does not increase. The second paper I want to mention by our group member Daraj it's also on the same theme, how can humans be involved in this fact-checking paradigm. So what they presented is a Co-Verify. It's a web-based COVID-19 news feed that it displays credibility ratings as well as user votes. And the users will be allowed to vote, and in that way, the users will be able to provide veracity labels to news articles, and in the end will enable crowdsourcing of fact-checking. So what we see here is the Raj and colleagues basically enabled crowdsourcing as a means for fact-checking, enabling community to really engage in this, and also testing the veracity and efficacy of crowdsourcing fact checks. So here comes another question. Who do users trust? And this is work by Min and colleagues. So the question there is, we have so many people skeptical about online content, and there is so much harmful, hyper-partisan disinformation and misinformation around. So, and there, partisans really tend to believe news that aligns with their beliefs, regardless of truthfulness, because of the confirmation bias. So, if we do provide fact-checking, will they actually believe it? And that question depends on who provides the fact-check labels. Is it the algorithm? Is it a third-party fact-checking? Or is it actually communities, other users in the same social network? So what this work did was they conducted a user study of around 1,600 subjects, and what they're presented was fake news and labels that says, okay, this news is kind of fake, but then who said it's fake? Right? It could be the algorithm, where the user will see that you may know that this post accuracy is disputed by misinformation detection algorithm. And when the user hovers on the interface, they'll see there's this hypertext with more explanation. Like, we worked with third-party fact checkers to develop an algorithm. Our algorithm helps us detect misinformation quickly and accurately. Or the user could see a community kind of label, and they would see, okay, so this post's accuracy is disputed by other users checking misinformation. And the explanation details on that. Or the user could see that the label, the truthfulness label, is actually provided by a third-party fact checker with the hypertext explaining more. So the question really is, are there differences that will change the user's belief in the fake news given these different labels? And what they found is really compelling. They found that algorithm labels, those produced by the machines, can be effective in hyperpartisan misinformation context. Specifically, these algorithm misinformation labels, rather than community labels, actually, can be more effective in reducing conservative readers' beliefs in fake news, particularly when the news does not align with their original partisan belief. For liberal users, all three are effective, but the algorithm one is more for conservative users. And this echoes some of the research that's out there saying people perceive the algorithm as more neutral. And finally, so far we have explored kind of fact-checking and how humans can engage in the fact-checking process and what kind of label would affect human belief or disbelief in fake news. But we have yet to talk about how do we open up the opaque AI box to have models explain their decisions. So we have taken the first step on that, and this is joint work with Matt and myself, with our students and postdoc. Here's the general idea. We have some text. Let's say we are trying to detect exaggeration language. So if I say his ego is the size of Mount Rushmore, you would kind of see, okay, this is kind of exaggerating. And the machine, without any explainability component, will tell you, I predict this is exaggeration. What we enabled is for the machine to tell you, based on its training data, what kind of examples the machine is able to retrieve to say, I made this decision based on these examples in my data. So for example, The closest examples could be things like your decrepit furniture seems to be from the Jurassic era, or I had to finally switch off the fan as it threatens to blow me away, and so on. So what we try to use is this thing called a prototype tensor, where we learn latent clusters within the training data, and we directly use this kind of clusters to inform the model decision. And what we call this is a global level of explanation, in the sense that we don't focus on just this single input and getting the part of the input that informs the model decision. Rather, we go back and look at what kind of training data is the most responsible one. What we are able to show is that this type of model performs on par with existing large-scale pre-trained models in natural language processing, so no loss in accuracy. On the other hand, we have the added benefit for providing users with the explanations using these prototype layers and tensors in the middle. And in addition, if we present this to the users to tell them, hey, can you do better with a downstream task given these new examples, they actually do. So they perform much better when A, the model is more accurate, and B, they're able to get training examples to both predict model behavior and to better understand the task. And some of our future steps include, like, we want to enable this local explanation as well, so which part of the input would the model actually focus on. As a summary, our team focuses on designing responsible AI systems to curb disinformation and misinformation, and designing responsible AI technologies to curb the spread of misinformation, and B, using this as a real-world challenge to provide learn broader lessons to build, design, and evaluate responsible AI technologies. Yeah, and I think that's it for the presentation. Thank you very much.
Questions?
All right, hello, thank you so much. This was extremely interesting. My name is Madeline. I'm a nutrition student that's really interested in the spread of nutrition misinformation, and particularly where that information is coming from. So I was really interested in the study about the hypertext and sort of explaining where that information came from. And I know you mentioned that there were the third party. Yeah, it might be helpful to bring that back up. The third party, with third party fact checkers. So can you expand on what you mean by third party? So these people were maybe not politically affiliated, or a little bit more about what you were going for there?
I think here it means kind of an organization that just professionally provides fact-checking services. But Min, you're here, so maybe you want to explain a bit more?
Yeah, so Jessy's correct, like the organization like
Yes, so we meant third-party organization who do full fact-checking as their professional work. So like PolitiFact or professional fact checkers. Yeah.
Thank you. I just asked because a lot of times with nutrition, it's like, oh, my healthcare provider is a reliable source, but sometimes we don't know.
Yeah. So what these websites, they typically have a website, and they have a group of people who goes in there, look at every piece of evidence, tries to sift through. So you'll have like a claim, and then it comes with an article, and the article is like really long with like 100 citations, and say, okay, this we think is true, or this we think is false. Yeah.
Two questions over here.
Oh, okay. I have a question. I'm a PhD student in iSchool, and I'm curious about how you use the algorithm. Just you said like the local explanation and global explanation, but I feel like in this case, it seems machines can identify some like keywords about exaggeration, but I'm curious whether machines can learn like the logical, whether the logical is consistent in the like fake news and to help label. Yeah, I'm curious about it.
Yeah,
you.
that's a really good question, and honestly, this is one of our future directions. So far, we have looked at an algorithm taking one input and say this is of class X. However, in order to provide reasoning and to really examine what goes beyond kind of, hey, this is an example and this is how the class is, we need multiple encoders. So we need to encode the evidence as well as the actual fake news piece itself. And we would then be able to train machines to enable the reasoning between the two. So this is one of our next steps, and we hope, yes, the answer would be, if we cluster the data in a way that kind of similar reasonings actually are closer together, that will be a really good and positive indication to say that the machine is getting at some reasoning. Yeah.
Hi, so I'm an iSchool master's student focusing on user experience and research. And on the topic of designing responsible AI systems, I previously did some research into the design and utility of chatbots to help curb the misinformation. And a large part of curbing misinformation was people being motivated to even engage with the fact that they need to sort of understand what they're taking in is false or not. And so I guess my first question is chatbots or something like that an interest for this project? And second, on the topic of designing, I found out how a lot of the users would lose interest in even engaging with the chatbots that are out there just because of either just mundane designs or the AI natural language technology having a lot of limitations. So where do you see this going?
Yeah, thanks a lot for the question. Even though this project so far we have not explicitly discussed chatbots, there are issues with chatbots, exactly like you said. And in the field of natural language processing, there are issues like there's biases, things like racism and sexism that's produced as kind of the language of the chatbots, as replies to so if you have kind of harmful text and then you ask a chatbot to reply to that text, it actually doesn't perceive that it is harmful. So there are a lot of issues, and it can be one of the key driving parts for AI in general. And this is where we say we do hope to study misinformation and disinformation and broaden kind of as a foundational real world situation for us to study this kind of bias. I'm sorry, what's our second question?
So the second question was more about the motivation of people.
Oh yeah, so when they get tired and yeah. This is a very interesting hypothesis, and I think we need to go back and discuss because I think it has broad implications of fact-checking because fact-checking does not entail that, okay, here you have a piece of claim and then you just go there and there is something on the internet that will tell you whether it's true or false. Rather, it is a baggage of different types of questions that can actually be asked, and you need to answer each individual sub-questions in order to come up with the final label. And in fact, this is something that Greg Durrett, who is also on the team, has been doing. And I could perceive a kind of a very interactive component into it. But yeah, I'm not sure how kind of users will be able to react with this kind of system, but that's a really good question. Thank you.
And we have several more questions, but we must move on. Thank Jessy so much for the fantastic.
Thank you.